Thanks a lot for coming. I really honored actually to have the opportunity to speak to you today. I'm actually not going to be saying a lot about Hadoop, oddly enough, but I'm going to be talking about a lot of tricks that we're implementing at our company to make your analytics on Hadoop actually work. My name is Tyler Mitchell. I'm a software engineer in our Center of Excellence group that's specifically focused on R&D in Hadoop environment, but also supporting sales and other issues like that. First thing, I really don't want to give this talk for two reasons. One is because some coworkers came, so they're going to see that I'm actually giving away information that's really kind of behind the scenes, telling you how our software works. So if you're engineering the next generation SQL database on Hadoop, you're not allowed to take any photos. Just kidding. And the other reason I don't want to give this is because I actually had a bit of a conflict when I saw it that it's 10 years Hadoop, yay! And we're still talking about how to get analytics into production. Anybody else see the dissonance there with mature technology? Is really, we're still looking for it. And every trade show I'm at, I look around at the booths that are on the expo floor, and I expect next year there'll be half of those booths are gone because they didn't make a go of it. But they'll be replaced with another new half of the floor that's trying out something new. So that's where we kind of come in with what I'm looking at. This is just what we're going to go over. I'm including some benchmarking results near the end of the presentation just to suck you in and make you stay because you can see the pretty graphs at the end. But we're going to also talk about what I was just kind of alluding to, how we're stuck where we're at with performance-related questions. And I'm going to give for a couple different perspectives on what I'm calling best practices. According to me, I've been working with Hadoop technology just for a few years, so if you're kind of new to Hadoop, I feel your pain, I know what you're going through, and if you're absolutely new to Hadoop, I know what you're going to be going through, and our customers know what you're going to go through. So I'm hoping that I can spare you some of that pain by revealing what you need to look for in a next generation analytical environment on Hadoop. And specifically, I'm focused on a database that runs in Hadoop. That's our product. You can come to our booth and learn more about it. I'll talk more about it. But I'm going to be focused on the performance kind of innovations that we've put into our product, which are generally applicable, really, things that you should know about and watch for as you develop your own solution, whether or not you go with ours. It's not specifically a sales pitch, but it's really an engineering pitch to say, look, here are the issues that you should be considering when you're adopting a SQL on Hadoop platform. Anyway, and I'm going to touch on a couple of business cases just so you get a feel for how performance and stability and enterprise capabilities translate into producing business-changing results. Because if they don't produce business-changing results, if they remain as a development project, then they're useless and they're a waste of your time. So Actian, a lot of people don't know our name that well yet. We're the Ingress Corporation. These are the companies that are part of us that we have purchased or built or acquired over the last few years. Just in the last few years, we acquired Versant, Parexel, and Pervasive. Those are the start dates of the companies. I put them specifically on there with those dates to show you that our lineage is in database, analytics, even transactional databases, embedded databases, data integration, and now in the big data space, analytics in a clustered Hadoop environment. But we also have experience in non-Hadoop clustered environments with the Parexel database engine. So we are not new to the show in that we've developed query optimizers. We understand what these mean, things that some people are just starting to learn about after they've hit performance issues in their little read-only database environment. Our company, it's 400 plus employees. We're in a few different sectors. We have three businesses, as I was just alluding to. We have data management, kind of traditional databases. We have a data integration side, which is cloud integration, ETL type environments. And we have a big data analytics business, and that's what I'm representing here today, and our booth is on the floor. So that's just to say, among these employees, we've got this experience, and I'm trying to share a little bit of that experience with you today because it's not easily won experience. When you have to generate or regenerate code from scratch to optimize performance, it takes a bit of work and it takes a lot of experience with those platforms to really make an impact. So I say, how did we get stuck here? I like this little pretty picture of what I'm calling an accidental Hadoop experience, because most of us didn't come out seeking Hadoop. How many people, and you can close your eyes if you want to put your hand up, how many people have already put a Hadoop analytics system into production here today? Anybody? Okay, so that's about 10 people out of, I don't know, 80. How many haven't done it but have to this year or else? Yeah, same, a few more than that. And how many are just kicking tires to learn a bit more about Hadoop at this event? And it's almost like a 1/3 split there between you guys. If you have fit some other scenario, come and tell me afterwards so I can ask a better question next time. But this is what I see. I summarize our whole business as data capturing side of the business, fairly straightforward. We know what information we have to collect. The business kind of defines that for us. IT and engineering gets involved with how to host that data, hold the data, how to warehouse it, and then we serve it up to some kind of BI tools, analytic scripts, SQL environments, and then we make some kind of a solution based on top of that, and everyone's happy if we get through that transition. Now, I think half of you can probably figure out where this is going. And a couple years ago, we just dropped this little Hadoop thing into our data infrastructure, and we say, oh, look, we've got a new way of holding larger amounts of data or processing and distributing load across our cluster. And this Hadoop data storage thing, HDFS, is really good, and we're going to try it, and we're going to start creating a data lake. But what happens is you throw it in, and then you're going, well, how do we do our analytics? We need custom programming to do this. What the heck? Okay, we'll start a little R&D project, and in a year from now, they'll solve all those problems. We know that doesn't happen, and that's not a real-world scenario. I mean, the production side doesn't become a real-world scenario. And then solutions, of course, is left wondering, when are we going to get something that impacts the business? And now Hadoop branches out. We can say Hadoop branches out into analytics in a way. It's taken over more of your space. It's eating more of your world as it kind of moves across there, and we're still stuck with trying to figure out what's the solution to producing adequate products that solve a business need. So that's the journey that all of us have gone through at some point in time. You maybe solved some of these and have some solutions built on this now. And obviously, many of us vendors are selling solutions built on this to help solve these problems. Now I'm switching totally to a business slide here to say this is what we have to look at as a solution provider to solve for potential customers. These are the same issues, though more or less, that you need to be able to solve to have a production solution for yourself. We can go through performance that meets SLAs, leverage the existing SQL skills you have in your organization. That's a challenge with Hadoop. Sometimes you need different set of skills, different people, different programmers to extract the value from your data. Well, we want to leverage the existing SQL skills you have by giving you a SQL interface to your data like you have been using for the last 20 years. But ultimately, if we don't create new business or grow revenue, there's not a lot of point in doing any of this. Sorry, researchers in the room, but from the business side. And not only do we need to kind of maintain kind of traditional database environment for interacting and analyzing data, but we also have to do it across more sectors now than ever. I know the previous presentation mentioned the problem of moving into the cloud for some companies, or some of these sectors, for example, don't like to go into the public cloud. Well, it's an equally big problem to say now we actually have to service with the same technology foundation. We need to service all these sectors with different kinds of analytics, high-speed analytics, secure analytics, in-stream analytics, whatever. So we've got a wide range of use cases that we have to actually service with your production environment. So that might seem a little bit of a detour to say, how did we end up where we're at? Well, we ended up where we're at because we created an environment where we didn't have one specific winner. We have a broad platform, the Hadoop platform, we could say. And I'm generalizing terms, I know, so don't take me to task on it. but a generalized platform with a ton of options. Now, I know open source really well, and I know one of its biggest strengths is the modularity. So you're not stuck with one thing. You can pull it out, plug in a new analytic engine, plug in a different database, plug in a new operating system or a different distribution. We can do those things, but it's also its biggest weakness when it comes down to having to design a system that maybe has multiple components depending on each other with many points of failure. So we're struggling still from the sense of presentations and the customers we talk to with that problem. This is really for those that are really new to the environment, so a third of you, that are new to the big data concepts maybe, and these are my top 3. Well, before we get to the top 3, you take nothing for granted in a big data environment. I still remember the day I loaded my first data set into a Hadoop environment, and it really didn't get partitioned properly. Well, we'll come to partitioning in a second. But I took it for granted that it understood enough about what I was thinking and my desire and my needs. We can't take those kinds of things for granted, that it's going to be using a memory in an optimal way. I'm getting ahead of myself because those are going to be other points. But don't take anything for granted with the environment you're moving into. If you don't understand how the memory is used, how the processors are used, how your data is handled and stored, then you're going to be at a disadvantage when someone starts asking you, why is this underperforming? Partitioning, I say versus data skew, but partitioning and data skew, if they're new terms to you, please look them up. My explanation won't do justice for you. But when your data is spread out into pieces across the Hadoop environment, it can have varying levels of impact depending on how it's partitioned. If you might think that you want to split your data up by month of the year, but then you find out later on that all of your retail examples happen in the middle of the summer, and therefore only half your data nodes are being used effectively. Those are issues. The data skew is the same idea, that you've got data that's heavier in one node than in another. Issues, these are concepts that if you haven't nailed them down, you're going to need to know them, and your boss is going to expect you to know them. Ask me how I know. The data types matter as well. We tend to think that the data lake, we're dumping data in, and it doesn't really matter what it is, just throw it in. Well, it does really matter what it is, because when you want to do analytics on it later, you're going to hit hurdles with how your data is formatted. If the data you threw in could have been formatted differently when you dumped it in, say you were doing an extract from a data warehouse, and you could have extracted that Boolean field as an integer instead of a 5 varchar string, you would actually have reduced your space requirements for that column by 1/5 or 4/5. So, as an example, data types matter especially when you're dumping data into your data lake. Even though kind of the common story is that just dump your stuff in, we'll figure it out later. But most of us have an opportunity to tweak our data when we're ingesting it into the data lake. So back up and think about it and see if you can improve it. Again, things to look into later on, and they're really out of the scope of what I'm talking about. But maximizing memory, if you're running in MapReduce jobs or you're doing custom Java coding and things like that, you don't always have the memory control that you want to have. That's just one example. Remember that it won't be using memory perfectly the way that you think it is 90% of the time. There's bottlenecks that are happening throughout your system, from loading the data off the disks, transferring across the network connects, loading it into memory, processing the CPU. All of these things are potential bottlenecks that you're going to have to bite off and handle. And the fourth point out of my 3 is take nothing for granted. And I won't repeat that again, but please, that's really what these points are all about. I'd like to spend a fair chunk of the next few minutes talking about what we've implemented as I'm calling 6 games changing database innovations that we've implemented into our vector on Hadoop SQL enterprise database. So I'll try not to say all that again, but these are what we've engineered from the ground up. We had some R&D projects 7-8 years ago that produced a single node, fastest performing TPCH benchmark application, database application out there. These are what we implemented, and we continue to implement them, and now we've distributed across Hadoop. So you've got this super powerful database engine running on all your data nodes. So that's what I'm generally talking about. Now, you could implement this kind of stuff in your own custom application. That's why this isn't just a sales pitch, but you could go away now and engineer this stuff into your product and rip us off. And if you do that, come and talk to us because we have engineering jobs open. So vector processing. Anybody familiar with vector processing? Anybody? Anybody? Okay. Well, I might get one of you guys to come up and explain it then. Here, I'll summarize them. Use the CPU. Use it effectively. CPUs have actually changed over the decades since many traditional database technologies were invented. Now we have ways of loading in chunks of data with one instruction to say, once this data is ready to go, run this analysis on, or for lack of a better term, run this function on this data chunk. Instead of saying, oh, here's a piece of data, run this instruction, here's another piece of data, run this instruction, instead we vectorize it, it's called, we load her up in, and we fire off, they call it single instruction, multiple data. It's a high performance way of using your CPU. These capabilities have to be engineered in the database product itself to use them. You don't just get it for free by putting it in the latest Intel CPU. If it's not programmed in at the lowest level, then you don't have access to this kind of capability. Minimizing bottlenecks by exploiting the chip cache. Now, in our system, memory actually becomes our bottleneck really, really easily. Memory speed becomes our bottleneck. So what we do is we pipeline our data into the chip cache, and we use it to do as much of our decompression and our prepping of that vectorized data as possible right in the chip. So our developers need to know enough about what standard hardware looks like for making that happen. And that's a big bonus. So each one of these things can give you 5-10% performance improvement on average. So you can see why we can come out with orders of magnitude faster processing than others that don't implement these solutions do. You're going to hear me say that over and over. Do you have a columnar database? And we're not just talking about a NoSQL columnar thing. This is SQL on Hadoop, columnar database. By storing your columns of data in their own blocks and in contiguous blocks on the actual HDFS, we can actually take that and it, oddly enough, starts to look like a vector that then goes into the CPU cache, that then goes into the CPU, and then is pipelined right through. So we actually optimize that using this vectorized approach. Again, it's a word, you can look it up, vector processing. We actually use it right down to the lowest level. And if you're choosing between two data products and one has a columnar and you're doing analytics, you're going to want to use it. We can actually do a lot of processing on columnar data faster than on row-based data, but I'll go into that maybe after if there's questions. Smarter compression. We have specific compression routines depending on what type of data it is. A lot of implementations of compression in the Hadoop environment are generic, and they say just compress all of this data the same way. Well, numeric data and text data compress differently, and there's different ways to optimize that. So we actually have some different algorithms for doing the compression. And again, we don't uncompress it until we get it into the chip cache. So you can see that we can actually reduce the amount of data that needs to be moved around. Smarter indexing. We don't need to read our data in these blocks to find out what's in them. We know what the mins and maxes are of each block that we have stored. So our system doesn't even actually have to touch the data before it knows where the data blocks are. And again, in a Hadoop environment, you want to reduce the amount of network communication that has to go on. So you want your data nodes to understand what they've got. And part of that is by having smarter indexing. Multi-core matters. We all know there's multi-cores in our systems. Oddly enough, I still fire up applications that use one core, and we all hate to see that unutilized core, right? Well, in the database world, we need to make sure that your system, that whatever system you're using, is engineered from the ground up to take advantage of those multi-cores, right? So anyway, these are our innovations. I'll come back to this slide near the end if you want to take a photo or whatever. We have it in our booth as well. Now I'm shifting gears again for kind of the other third of you. We have business use cases where when these kinds of technologies or improvements are involved, again, not a sales pitch, when you apply these kinds of engineering principles to your big data analytics project, it has a business impact on you and on your customers or on your business users. One example here, we took a telecom that had vast growing kind of customer 360, we call it, where they're dumping all their data from all their different sources of tracking their user experience. And they need to know and understand when something's failing, when someone's unhappy, when something's not working. And they weren't able to really do it to the level they wanted. They could only process a day worth of data or something like that. So the initial architecture was somewhat like this. They had several hundred nodes running Hive, and they had SQL users, so they had BI tools, and they had like R and some other stuff, I think, hitting it as well. But they had to pre-process the data. So, sorry, this is a direct copy out of one of our internal documents. The source tables are the blue things at the bottom, and they had to pre-process that, do all their joins as much as they could, plop it into some intermediate materialized views in Hive, and then they had to use that data to feed the BI tool. But even that pre-processing still took so long that they weren't able to get the results on as large a time frame as they wanted. So they had to look at small pieces, and it was continually frustrating for them. By implementing those performance improvements, moving their analytics to a high-performance production environment, we were able to actually run on 10% of the nodes. Again, because we're taking advantage of the CPU architecture and the memory and all these other improvements, if you don't take advantage of them, you're leaving them on the table. And that's why we can actually, when you optimize your analytics, you can actually run on fewer nodes than, say, out-of-the-box systems that aren't tuned or that aren't engineered to take advantage of that hardware. Of course, we all know that if you just throw new hardware at stuff, it goes faster. But when was the last time it went exponentially faster? To get that kind of performance, you have to re-engineer your platform. We didn't have to pre-process anything. In fact, we hate pre-processing stuff, partly because it just takes up more space. And in a big data environment, when you're running petabytes of data, you're not going to just, I'm going to make a copy of that and tweak a few variables. That's not really what you're interested in doing. So we were able to actually reduce their storage requirements. So there was no pre-processing. The compression was better because of our data format. And they actually ended up being able to do 2 years of data that were analyzed. And the result is 1,100 columns when stuff's joined together. And we actually do the join on demand. We don't actually manipulate the source data. And the BI tool can actually get a live data view of what they've got going on. So we are able to extend the amount of time that they could cover and analyze. And that's what big data is all about, right? Is being able to analyze larger pieces of data than you could before. If all we ever looked at was 1 month at a time, for example, then what would you need, to be able to hold all of years' worth in your data lake? We wouldn't be talking about it. So anyway, the result was good stuff. Okay, I won't belabor the point. We also did a financial risk proof of concept with a banking customer. And they had to generate risk risk reports at the end of the day, but it took 3 hours to generate. And if they didn't generate them right, they were out of compliance, yada, yada, yada. So, but the problem was that they were running in a single server architecture. They had many, many applications built on top of it. They used the SQL Server Analytics Service. So they had an OLAP and type environment with an analytics layer on top. And now they generated cubes. Again, look it up if you don't understand what the cube engines mean, but it's important because when we say pre-processing, we're often meaning cube generation. But their cubes became so large that actually the vendor was like, these are beyond the sizes of the cubes that we recommend you have, and 1.5 terabytes actually isn't that big now. They were unable to scale to the desired range where they were getting over 200 gigabytes of new data each day, and they wanted to be able to analyze that, but they couldn't at that rate keep up with being able to analyze a month at a time or 2 months at a time. And some of the products they were testing on Hadoop were failing. But they're highly invested in the apps that were built on their analysis service. So we had to keep that part of it, but we got rid of the cube generation. We were able to keep the data sources as pure as possible, not merging them all together, not pre-processing them. And we were able to do a bunch of tests from 1 terabyte to 20 terabytes at a time. Most of the queries that were focused on getting specific answers were in sub 2-second range. Other ones where we forced it to process all the data in the database, just as a benchmarking exercise, took maybe a minute and a half on 20 terabytes. So the point isn't what specific scores and timing and data sizes these guys processed, but the point was that by optimizing the engineering underneath, they were able to get their business questions answered in a timely manner. I can come back to this if you want some more stuff, but they were able to actually do more than just meet the bare minimum. They were able to run their queries and reports throughout the day now and adjust as they went on. So again, I say it, delivering the results with better engineering. Now I'll get into technical benchmarks. We ran, this is actually an audited TPCH benchmark at the 3 terabyte range. Do TPCH mean anything to anyone? I expect a third of you to know TPCH. But so database benchmark, industry standard. You voluntarily sign up and get it done. So not everybody does them. So we don't have thousands and thousands of competitors to compare ourselves against. But in this case, the metric on the y-axis is how many queries per hour, more or less, that could run. There's a standard set of queries that get run on all these platforms, so we can compare apples to apples at one respect here to show that we were actually, our closest competitor could only process half as much as we could. This is a single node version of our analytics engine called Vector, not Vector on Hadoop. And we've taken this engine and we've put it on all the data nodes in Hadoop. So you get this kind of performance. Yeah, do you have a question?
So by query per hour, you mean you run all 22 queries one by one, and then?
I'm not sure if it's just one metric that comes out of the analysis. They run all the queries. I think it's serially, and then they get the average or total queries per hour that come out. It's a TPCH benchmark terminology that I can't define really precisely for you, but
2 million queries per hour.
Something like that. Yes, that's right. That's right. That's the idea. I'm just trying. Query per hour makes sense, but then there's another H in there, and I'm kind of wondering what that means now. But if we had to use really expensive hardware to get to hardware or software to get to that point, that wouldn't have been as staggering for you. But we actually this is the cost per query per hour, if that makes sense. So our cost comes in much lower as well when all the hardware, again, if you're not using all your CPU and memory effectively, then you're throwing away your production costs. You're really just flushing them. Now, switching to a different benchmark, this one's a little more confusing to look at. We're not actually in the graph on the bottom. Ours benchmark is the one line across. Now, since you're not a big TPCH crowd, I'll explain this a little bit further for you. But this was on a clustered environment, 10-node cluster on Hadoop. And we compared ourselves to the other kind of Hadoop popular platforms that were out there. And we analyzed the queue numbers along the bottom are the query numbers. So each one is a set of queries that runs, and they measure how long it took. You measure it again for the next query. And in all cases, the better engineered product came back, our product came back and faster than all of them on every query. But the caveat is that actually some of these platforms didn't even complete some of the queries because they were too complex, and you can see the line going off the top and not coming back. And in some cases, we actually had to change the SQL to make it work with some of these other platforms, and we did that as well, so that we could at least get an answer back because they didn't support standard SQL, and we support standard SQL. You want your engine to support standard SQL. That's the takeaway point. So make sure that when you're choosing an engine, that you're not compromising what your BI tool can do by knocking the legs out from under it and saying, oh, we can only use certain select statements, for example. So in this case, it's a logarithmic scale. So in many cases, we were, almost all cases, we were 10 times faster than all of these competitors, and we are up to 1,000 times faster than several of the queries as well. That's what that's showing. we're basically 0, and these guys are how much longer they took to run. I'm almost near the end here. The previous results, I should say this screen, as well as this screen, are extracts from a special interest group of database engineering, SIGMOD. So there's a SIGMOD conference tomorrow. We're presenting this. Our researchers are presenting this paper going through all these results. So if you're going to be at that event, you can get even more detailed explanation. But this just showed that we have also, by engineering better compression into your product, you can, for example, I should start with saying our min-max indexing. By using intelligent indexing, without having to actually touch the data blocks to find out what's in them, you can reduce the amount of time it takes to run your queries because it doesn't have to touch as much data. And that's what the top box represents. You can kind of ignore the four sections there. It's just more increasing complexity or touching more data in these different queries. So you can see that the higher the line, the more seconds it ran to do the queries. And our product, the vector product, isn't even showing up on the chart in the top one. It's the fourth bar. When we get into data reading, we can compress our data, and the amount of data that actually gets read is lower as well. And that's what the second chart shows. So for example, with Presto, with ORC files, it had to read all of this data to be able, at up to 3 gigabytes of data to get the query response. We were down at less than 1 gigabyte for all of them, and even the first two, first two types of queries was even less. So those maybe aren't as impressive to you, but when we talk about compression, our experiments showed the bottom right example, where your data is compressed, it takes up less space than Parquet and ORC. And again, Parquet is kind of doing a general compression here from my understanding. It's not, if they switch to doing more compression based on the data type, you could actually get that down as well. So I know next year these results might be a little different as competitive products implement similar concepts and solutions. But you can implement them too, especially if you're coding some stuff from scratch and developing a solution today. So my 2 summary points here. I say it takes Hadoop to a new level, but really it takes it to the level that you were expecting, maybe taking for granted that it would. To the expected production level is really what we're aiming for. And this end result is being able to move from development into production while still delivering the business results that you require. Now, just a word about moving from development into production. We see a lot of customers that come where they've worked for several years on using a specific tool. They threw all their data in. They started using this tool. It worked on a proof of concept stage, but then when they scaled it out, it didn't work. It wasn't efficient enough, or it was slow, or it broke, or those are all scenarios that we see every month as we're dealing with new customers. And they can't get into production. And part of that is juggling the various components. So you've got, just managing Hadoop is complicated enough. And then if you're going to run several subsystems in Hadoop, you need to understand that even more. But the goal here is, and again, not just about our product, but about any product you choose, the more cohesive of an environment you have, the better, with the fewest moving parts that can get out of sync with each other. I've seen some cube examples, for example, the Keylin project, I was watching a presentation about it, and they were showing how you moved your data out of HDFS, or you processed it with Hive, you saved it here, you made another table with Hive, you served it up with this other program to give you a SQL interface to it, and then you had another set of tools that regenerated the cubes. Like, all these hanging components mean you, in production, need to have people and skills to support all of those moving pieces. So try to keep your solution as tight as possible, is my point. Again, I just keep flashing this up. Actually, I added a footnote on this one saying our release that's coming out in the next month will include Spark. So we have a proprietary data format, but we have an open API, so you can program against it. And But we also are adding in external table support so that we can actually read Parquet and ORC files and other files through Spark if we want. Now, you're going to compromise probably on performance a bit because our format was optimized from the bottom up to feed into the CPU, right? But because it's a proprietary data format, some people, oh, forget it, I'm only open source data format or open data formats. And we are open in that you can still program against them and you can still access your other tables and just use our engine to actually do your analytics. And we're integrating with Spark so that you can actually call our database from Spark and read data through Spark as well. So next year we'll be showing that off at this event. So that's, oh yeah, and then that's the pitch for the paper that's at the SIGMOD conference. You'll probably be able to find that in a press release or on our website soon. Again, this is research that's serious academic level research on our product, but showing those results that I've showed you today so that you can have a takeaway that's saying the latest in Hadoop-based SQL analytic databases has found these results in their research. It shows where they were able to push the envelope even further than they did before, which was already amazing. So if you can find this paper online, or if you have access to it somewhere, it'll be a very good read for you. It's very technical, but very deep. And we're just privileged to have enough people that can actually do this kind of research within our organization. And we're always looking for more. This is how you can contact me for any questions, and visit us at the booth here all week. Thank you very much for your attention. We have time for some questions. Yeah, I don't know. The question was about chipsets for CPU optimization. I'm really not the right guy to answer the question, but the questions come up in other venues too, where are we stuck with having to use on-prem only, for example. But no, we do actually take advantage of the other CPUs. I don't know enough about CPU architecture to say the difference between AMD or Intel or whatever. My assumption is that this SIMD architecture is across chips, but I don't know. Does anyone else know that? Sorry. But I have never heard of it being an issue. So. Any other questions? Yes? Cost per node, yeah, again, I'm the wrong guy. Unfortunately, I'm like in between engineering and sales. And they say don't talk sales and don't talk engineering, so I just talk this stuff. But yeah, we license it usually per core, I think. I can connect you with sales to give you a better answer.
So,
yes?
do we have to migrate the data to start with this platform?
Yeah. Yeah, more or less. So until our current version, our new version coming out, we'll be able to read the tables that you've already got stored on HDFS. It won't be optimal, but it will work. The typical scenario is, yeah, you would do a data load into the database like you would in any other database. So there's a load step where it loads it into our blocks in our format. And also, we should say, our system actually talks to Hadoop's name node to keep track of where all of our data is and adjust it accordingly to make sure it's partitioned well. Whereas a lot of other solutions, they'll let you partition it when you dump it in, but then that's it. If you change it and skew your data one way, it can't always manage it. But does that answer your question? Yeah. Yes?
For how long will you load the data to the optimization?
How long does it take to load the data into our system? Good question. I don't know. We do terabytes per hour is what most customers require. Yeah. I don't know if that's a goal or if it's something we're already meeting, but I know I've seen that 1.5 terabytes was a goal for one customer, and we seem to be meeting that requirement.
Do you support any type of stored procedures within your database?
No, we don't. We are coming up with some even user-defined functions. We're implementing most of that through Spark. So when we get to that stage and you want to script stuff, again, we're kind of more like load your data, use your BI tool.
Okay.
You know what I mean? But it is an issue for customers who are moving off of platforms that have a whole bunch of stored procedures. And we have different ways of suggesting they do it, but we don't have, well, I should back up and say we have other database products as well are the Parexel database. Now it's called Matrix, is an MPP database that runs outside of Hadoop on any kind of cluster. It has stored procedures in it as well.
Okay.
And yeah, and if there were stored procedures, it's a challenge starts to become how to parallelize that in a Hadoop environment.
Correct.
So does the product come with a performance monitoring tool?
Not particularly, no. I mean, you can run your TPCH stuff against it, but we use Embari and plug into the Hadoop ecosystem, so you'd monitor your stuff that way. I'm sure we're coming out with something, but I can't say about it right now. Oh, time is up. Thank you very much. Sorry, I'm being signal. You can come and ask me. Thank you.